Can you see those lines? Can you see that intersection? We got an arc, we've got an arc, we've got a straight line, we've got a straight line, and this is exactly 90 degrees. Let me show you how I did that with a tape, a board, and a pencil. So the first thing that I'm going to do here is pretend there's not a straight edge on this piece of material, nothing to work off of, so I'm going to get the line like this. And I'm also going to measure this board. It's 45, a little less, so the midpoint is 22.5, a little less. Ba-boom. Midpoint ends. Next move, it's just throw on a couple of arcs. Now I did this a little rough, obviously. I just hooked the tape on the pencil, and I arbitrarily picked 30 inches. Yeah, 30 inches is probably going to work, and I scribed an arc. And I did the same thing off the other end of the 45-inch long line. 30 inches, hooked the pencil, scribed an arc. The intersection of those arcs is 90 degrees from the midline on the baseline, which we already established at 22 and 7/16. We threw the board on here, struck a line. Let's check it. Baseline. Look at that, my friends. I should have paid a little more attention in geometry, but I guess I paid attention enough. Now, there are not many opportunities when you're going to need or have to be able to do that. So let's talk about some of the other ways where you have a few more tools, a little more resource at your disposal. The Egyptians made those pyramids exactly square. I think they must have used the Pythagorean theorem. Those people were smart. That is, a squared plus b squared equals c squared, and we did a video all about this when I was building Amanda's garage. So whether you're laying out a foundation or squaring up a cabinet, or maybe you're joisting a floor on a foundation that wasn't square, somehow you've got to be able to square up a shape. Now, we're getting back to the assertion that since the beginning of time, people have measured the diagonals on a rectangle or a square and adjusted their batter boards until the diagonals matched. But you can waste a lot of time like that, going back and forth and subtracting a half you can kill a day pretty fast doing that on a complicated structure. The better way is to use a little math, and it's this. Let's imagine that instead of 4 feet by 8 feet, we wanted a rectangle that is 4 feet by 5 feet. So, if you're doing a foundation, you set up string lines parallel on one of the dimensions, let's say the 4-foot dimension. We know it's straight, we know it's straight. We calculate the hypotenuse, which is the line that goes from one corner to the other corner. That's the hypotenuse of a right triangle. You got to remember that, boys and girls. The hypotenuse is the long side of a right triangle. In this case, we have a right triangle that's 4 feet, 5 feet. We need to find out what the hypotenuse is. If we call this A and this B, we're going to call this C. What in the world is C? Well, C is 4 squared plus 5 squared equals C squared. A squared plus B squared equals C squared. So what we want is the square root of C. 4 squared is 16. 5 squared is 25. 16 plus 25 is 30. 41. Thank you very much. So what we want to find is the square root of 41. Mr. Apple tells me the square root of 41 equals 6 0.40 feet. Let's convert 0.40 into a fraction, should we? 0.40 times 12, 12 inches per foot, 0.40 feet. 0.40 times 12 equals 6 feet, 4.8 inches. We don't want to use 0.8, so we're going to take 0.8 times 16, 0.8 times 16 equals 12.8 sixteenths, which is the same as 13 sixteenths. So we know we have 6 feet, 4 and 13 sixteenths. Now, aren't you guys depressed that you're stuck with the metric system? So now let's check to see how the math, a squared plus b squared equals c squared, on a 4 foot by 5 foot triangle corresponds to a real life condition. 4 feet, we know we've got it. A hair over. Darn plywood. 5 feet. Right there. We're looking for 6 foot 4 and 13 sixteenths, and we have 6 foot 4 and 13 sixteenths. That's pretty good. Can you see how that would save hours of time? Stretch a string line, pick a control point, measure down 4 foot, or measure down 5 foot, and then from that 5 foot, measure over onto the other string line 6 foot 4 and 13 sixteenths, or whatever your diagonal dimension is. Make a mark. Now from that mark, it's the same 5 feet. Bam! Those lines are square. That's much faster than adjusting diagonals with two guys walking an end of a tape back and forth and adjusting the strings 1/8 of an inch at a time. Use good old Pythagoras' brilliant insight. So the thumbnail version of that is that a 3, 4, 5 triangle is square. Can you see it's the same thing broken down to its simplest components? Think of a squared, b squared, c squared. Any triangle that is 3, let's call this 3 feet. It could be 3 inches or 3 miles. 3. By 4, it could be 4 feet, 4 inches, 4 miles. It doesn't matter. 4 is going to be 5 of the same units across a hypotenuse. Right there. 3, 4, 5. That means that is exactly 90 degrees. Now here's the next step. Any multiple of 3, 4, 5 that is the same in all three cases, like 30, 40, 50, 300, 400, 500. Or let's multiply the 3, the 4, and the 5 by 6. 3 times 6 is 18. Let's just put it down here. Times 6 equals 18. 4 times 6 equals 24. 5 times 6 equals 30. That means a triangle that is 18 by 24 is going to be 30 across the hypotenuse. Bingo! The applications of that are utterly endless, so keep your eyes open. All right, so that's all the math that we're going to throw into this. Let's just get down to some more direct, hands-on, got the tools, got the pencil. What you don't have is the time. What are some of the fast ways to make a square line up close and personal when time is what you're fighting? So we're going to talk about squares in a minute, but sometimes if you're on a roof or on a deck, sometimes faster than getting out your, just a second, there we go, faster than getting out a pencil and making a mark and stretching a chalk line and popping it. Sometimes you look around and there's a piece of plywood. Here's a factory in. That is a 4 foot by 8 foot square right there. And sometimes you can save a little time by just grabbing a piece of plywood, because nowadays they are very square, sliding it down to your mark, and using that for a big square. Now, it doesn't always work, and it works better if you've got a cut-off end of a piece of plywood, and you can't do it on a steep roof, but just understand that anytime you see a piece of plywood laying around with a 90-degree corner that hasn't been messed with on either side, you got a nice, regular, portable, it's a great square, so don't be afraid to use it. So about 80 times out of 100, if you need a square mark, you're going to grab a square. I mean, that's what they're for after all. And I've got a little assortment here, with this being one, the steel square, the framing square, that solves most of the problems. And they are direct and they are useful, and as long as your square's not been racked or bent, they'll keep you out of trouble. In general, the bigger the square, the bigger the possibility of it having been hurt. I mean, drywall squares are awesome, and I just want to trust them all the time, and I think this one's good. And look at that, I mean, that is hard to beat. So drywall squares, you ought to have one, even if you're not a drywaller. Sometimes you just need them. We've got a video about the steel square, the framing square. This thing is a calculator, it's everything. It's a scribe, it's everything a carpenter needs, and not a lot more. This is aluminum, by the way, which is in a lot of ways better than steel, mostly because it doesn't get so hot. But I mean, you got calibrated and measurable distances, and so nice and square, easy enough to check, easy enough to fix. We'll talk about that in a minute. As we move down, you can get squares in all sizes. I've got this, it's 12 by 8. I use that for fabricating mostly. This is down to 8 by 6. And in general, I think the accuracy probably increases because it hasn't been dropped off a second-story building onto a slab ever, so it's probably better. Tri-squares are only as good as the mechanism is and the wear, but there's all sorts of things you can do with this. I mean, that's handy. And then these are an older style in a finish work application nowadays, that they're elegant. I'm not sure they're all that practical, at least in rougher carpentry. So grab a square, own one of these, have a rufus, have a squangle, have a speed square, some kind of a square, you got to have it, and most of the time you can trust them. Now, I remember when I was a kid, I was just starting out, and Neil Hart was my carpenter mentor. He was the mayor of Dixonville. He owned the Dixonville store. He was a prince of a man, Neil and Betty. I was in there telling him I had my first carpenter job, and I said, you know, I bought a tri-square, and I just don't think that thing reads square. Well, why, Scott? Well, I make the mark and I make the cut, and it's not square. And he said, Scott, and he put his hand on my shoulder, trust me when I tell you, it's not the square. And he was right. Now, sometimes it is the square, and you got to be able to check them. We got a video about all of that. But when you're starting out, don't be surprised if just because you can draw a square line, you can't quite seem to make a square cut, but it'll come. So the whole idea of cutting a line, we've got a video on that. We've got a video on Skillsaw Pro Tips. I mean, there's a lot to it, and it's muscle memory, but you're not going to cut any more square than the line is, so don't be afraid to stop the presses if you need to check your squares. And it almost always takes a square to check a square. And in general, the bigger the square is, the more likely it's been wrecked. But so far, see, these are all verifying each other pretty well. Yeah, certainly well enough. Now there's a little problem on the inside of this guy. I'll pay attention to that. The drywall square, miraculously, is still in good shape, at least out 2 feet. But since these things take such a terrible pounding, be cautious before you use these for marking out something that's accurate, critical. So checking a square. You know, we can back up to the deal about using Pythagorean theorem. You can figure the hypotenuse on a 24 by 16 inch leg and then throw your tape across there and see if it's right. That'll tell you. If it doesn't figure at 28 and 13/16, then you know something's wrong. But once you check your square, and I checked this the other day, so I know it's actually right, and this one's right, but this one's only right because I adjusted it a few years ago. And you can adjust a square by drawing a line from the outside corner to the inside corner, and then taking a center punch and punching. I started here, I punched 3 times to close the square. And then when I checked it, I had gone too far, so I had to punch twice here to open it back up. And what we have here is an old, much abused, cheap square that actually is square again. I mean, you don't have to be able to do that. But if you can do it, you know, sometime it's going to get you out of a jam, and maybe it'll get you a raise. So squares and levels and plumb bobs are brothers. They're complementary, they work together, and in many cases they're interchangeable. So let me show you what I mean. You don't have a square, but you got a level, and you need a square line, a square corner. You need 90-degree corners, maybe more than one. So you put your level up here, and you make a mark. Now maybe you know this, but you probably know somebody that doesn't. You don't have a square, but you've still got your level. Level off of plumb is square. Let's check it. And there we are. Level off of plumb is square. Square off of plumb is level. Square off of level is plumb. These things are all interchangeable, and if you don't have a level, a plumb bob will give it to you. So that's the reason for my observation, that these things are complementary, they're related, they are vitally important. So as you can tell, what we've got here is a 21st century device. This is a laser, a visible line laser that doesn't happen to be quite square to the wall, and so there's a little bit of distortion between the line that I got up there with my level. You can't shoot this at an angle and get 90s. At least that's what they tell me. But still, can we just throw down that this is a wonderful and time-saving tool? But the tool that really saves the time is the tool you've got if you don't have anything else. And so this gets back to a theme of mine that, man, it's a great thing to have tools. So let me just show you the last example of some way to find something that makes you think you've at least made an attempt to find a square line. So what I'm going to show you next is laughably rough unless it's all you've got and you're out on a hillside and you're trying to establish a fence line, or at least point yourself in the direction that a road might need to go, or in the direction to a survey marker or something. And what are you going to do? Well, if your arms are the same length, you can back up to what you know is a base straight line and get your arms oriented, and then look straight ahead and bring your arms forward. Now, if your fingertips are even, and like I say, if you're symmetric around your center axis and your arms are the same length, you know what? You're probably looking at something that is somewhere near square. Now, don't use that to lay out a foundation, but maybe you can use it to amaze your friends. Thanks for watching Essential Craftsman, and keep up the good work.